Hello everyone, my name is Sean Bautista and this is my major project for the EECS 1011 course. What I have with me right now is what I'd like to call a music box. As you can see, I only used one grove wire where I had to switch the yellow and white wires to access the A1 port on the board, as the A6 port on the light sensor does not seem to be working. The first feature we'll explore is when we turn the potentiometer all the way counterclockwise, setting it to 5 volts, and when we press the button, we should see the buzzer and LED turn on. The next feature we'll explore is when we turn the potentiometer all the way clockwise, setting it to 0 volts, and when we press the button, a live graph of the audio should appear. This is the collected data from the audio sensor. As we can see, the original average, and thresholded in audio level is shown. We can see the variations by just tapping on it, the audio sensor. If we want it to stop, we can press the button. The next feature we'll explore is when we turn the potentiometer slightly counterclockwise, we press the button. A song menu should appear. And the user is given 6 songs, and if we choose River Flows in You by Urema, amazing. And the next feature we'll explore is when we set the potentiometer to between 5 and 2.5 volts. And we press the button. The Morse code feature is enabled. And it prompts us, the user, to read or write. If we type read, it asks us for how many characters that we want to have. Let's go with 2. I believe the first one would be an H, and that would be an I. Another feature we'll explore is the piano. It asks us to input a piano key. Let's go with D5. And it plays the D5 note. We can also go with G5. Amazing. It doesn't have to be a single note, however. We can input a sequence of notes if we type sequence, and we'll have to input a piece somewhere. Let's go and just grab this real quick. If you want it to stop, we just simply type stop. It returns back to the loop, and if we close the box, it should terminate. And that is my major project. We will now explore the code of my major project. First, I define 2 variables, frequencies and notes, where it contains the frequencies and its corresponding notes right underneath it. As you can see, the C0 note corresponds to the frequency of 16.35 Hz. As for the main code, all of the code is encompassed under this while loop, and it terminates whenever the user closes the box. This part of the code is responsible for playing a tune whenever the user opens the box. When the user opens the box, the light sensor detects an increase in the light intensity, and it executes this part of the code. in this for loop, it would go through each individual note in this greeting array, find the location of the note in the notes, and then subsequently find its location in frequencies. And that's how it plays it. And the same goes for the closing tune. Whenever the user closes the box, the light sensor would detect a decrease in the light intensity and play each note in this goodbye array, and the code would terminate. Next, if the user turns the potentiometer all the way counterclockwise, setting it to 5 volts, and press the button, the LED and buzzer will turn on. A more sophisticated version of the Morse code feature is when the user slightly turns the potentiometer counterclockwise, setting it to a voltage value between 2.5 and 5 volts. They will be prompted with read or write. If the user types read, it will ask them for how many characters they wish to have. Let's say they inputted 2 characters. This will create two 1 by 14 arrays where the user will press a button. Whenever they press a button, it will insert a 1. If they don't press the button, a 0 is inputted in this NaN array. So once the user creates their Morse code sequences, it goes through the Morse chart, where it has 2 input variables, code and size. Code is the user-generated Morse code sequences, and size is the amount of characters. If you go to Morse chart, the chart contains all the possible Morse code sequences and their corresponding letters. It is the same in principle in finding the frequency from a note. In this function, there is a for loop, nested for loop with an if-else statement inside it. So the for loop would go through each individual character, the amount of characters the user inputted, starting with the first one. The first character is a 1 by 14 array Morse code sequence. It would check each sequence in this chart, and if one of them matches, and then the Morse code, and then you can see that letter from this is inserted into the variable letter here. And next, and it would repeat it for the remaining characters that the user has. And then after that, MATLAB would activate the LED and buzzer. If the user types write, it will ask them to input a word, all caps, and single quotes. I created another function called morseWrite, where it only has 1 input but 2 outputs. It is essentially the same as Morse chart. The next feature we'll go through is the animated graph, the live graph feature. It would plot the original, its moving average, its thresholded value, as well as its audio level. The original value is simply the voltage reading of the sound sensor. As for the moving average, I created another function called setFilter. setFilter would essentially remove the first element of an array, shift all the remaining elements towards the left, and the last element would be substituted with the new voltage reading. And then we would calculate the average of the values inside the filter. For the threshold value, I created another function called threshold, where it would has two input variables, value and size. Size would be the threshold value that you want, and value would be the average. So in the threshold value, it would go through each element in the array, check whether it's less than or equal to size. If it is, set it to 0. If it is greater, set it to 1. Simple. As for the audio level, I used y equals mx plus b to calculate the audio level. It'd go from 0 to 1, 0 being you can't hear it, to 1 being it is very, very loud. To calculate this, I simply substituted the max voltage. To calculate this, I determined the slope using the max voltage, where I set it as 4 volts and assigned it, let's say, x value of 1, and the minimum voltage is 0, and I gave 0 volts, and I gave that value an x value of 0. And then I calculated for b, which ended up being 0, and we're left with this equation. The average, the audio level would take the average and multiply it by 1/4, and that's how we get the audio level. Next, this is the song menu feature. It is activated whenever the user rotates the potentiometer, set it to a value between 0 and 2.5, and they press the button. A menu pops up with 6 songs, and the user would choose a single song, and through this for loop, essentially, it would go through each note. Each song has an array of notes, which is similar to that of the greeting and closing tunes, as I mentioned above, all the way. And essentially, the way to play the song is the same. In terms of the user input piano, this feature occurs when the user taps on the sound sensor, and it will prompt them to play a single piano key. It can be any piano key, D4, G5, F4, any piano key, and it will play its corresponding frequency. As well, if the user types sequence, they can play a sequence of songs if they put each note inside a square bracket. And the code can stop if the user types stop. And will return them to the main loop. If the user wants to terminate the code, they can simply shut the box, and this part of the code executes, plays a tune, sets I equals 0, and then that's how the code terminates.